Hi, and welcome to VMware Code. I'm Cody McCain, and today I have with me Antonin Bass. We are both contributors, and Antonin is a maintainer of Project Antrea and a staff engineer at VMware. Um, um, I'm a product manager at VMware as well. And today we have a really exciting set of tasks that we put together to both introduce Project Antrea and actually show you how to jump in and become a contributor and actually put together a feature. And we're going to do that live for you today. So to get started, what we're going to do today is take you on our developer journey and introduce you to first what is Project Antrea. And Project Antrea is a container networking interface, and so we're going to be talking a lot about Kubernetes today, modern application networking within a Kubernetes cluster. And so we'll spend a little bit of time here at the beginning, telling you a little bit more about what Project Antrea is and how it helps us to connect containers to the network when using Kubernetes. Uh, in the second part, we'll actually talk about how Antrea uses Prometheus. And we use Prometheus for surfacing all of the operating metrics that give us information about the load and health of Antrea, as well as what's happening in terms of current network flows. And then finally, what we're going to do is actually take you through a real life scenario where I've come to want to use an open source project, right? And we've all been in this situation where we've got a project and we want to use it, but it doesn't have that one feature that we really need. And that's the beauty about open source is that anybody can download the code, uh, pull down the assets from the repository and suggest a change and actually code and implement that change. And so that's what we're going to do today for you live is we're actually going to add a new feature to Antrea, take you through that process. And once we've kind of done all those three things, what we hope that you'll see is number one, um, the value that Antrea can bring to your Kubernetes project, and two, to show you how easy it is to jump in and get involved with an open source project like Antrea. So in this presentation today, we're going to be using a couple of developer tools that you'll want to have available. We're going to be using Git and Vagrant, which is going to help us set up some virtual machines. Project Entry is coded in Golang. You don't actually need Golang to build it, as we build in containers, but you may want to do some additional testing and have the Golang tools available for your IDE, for example. We'll also be using Docker to create containers, and we'll be using Ansible um, as part of the pre-scripted setup scripts that we use to provision a cluster for our testing. So, what I'm going to do first is hand it over to Antonin. He's going to take us through actually deploying a cluster that we're going to use today for our development and our testing. And he's going to take you through setting that up. Basically, it's going to be a couple of steps. I'm going to show you what those steps are. I'm going to turn it over to him. He's actually going to walk you through it. We're going to start the provisioning process. And once that gets started, while that's happening in the background, I'm going to introduce you to some of the fundamentals behind Antrea. So the first thing is that we're going to clone the repository from the VMware Tanzu GitHub repository, and it's just Antrea. Once we've cloned it, we actually have a makefile set up in that uh, project directory, and you just run make build, and that'll actually build Project Antrea. And this should work on Mac, Linux, and Windows. The next thing that we do is we're going to deploy a cluster. And so in deploying Antrea, we actually have a lot of really useful test scripts set up in our test directory under the end-to-end testing and infra subdirectories. There we have a Vagrant directory that has a script file called provision. And provision literally just calls out to Vagrant. Vagrant's going to create our virtual machines, make sure that they've got the right images, and then after those virtual machines come up and Kubernetes is running, we'll use another script called push Antrea that actually takes the Antrea images that were built in the previous step and copies those over to the image or to the virtual machines, and then loads them into Kubernetes using kubectl. So without further ado, and before we get into this, I'm going to pass it over to Antonin so he can actually start the provisioning process.
Thank you, Cody. So basically what I'm going to do now is I'm just going to run the steps that Cody showed to you on the slides. So hopefully my terminal font is large enough here. Let me just increase it a bit. There we go. So I'm going to create a directory for this session here. There we go. And the first thing I'm going to do is I'm going to clone the Antrea repo. So let me switch over to the GitHub webpage for Antrea. I'll click on code, copy the SSH URL here, go back to my terminal, and I'm going to do git clone and clone the repo, which should be pretty fast because the repo is not too large. We'll try to keep it small. I'm going to cd into Antrea, and I'm going to run the make command that Cody showed on the slides. So what this is going to do is this is going to pull like some base images we use for Antrea, which include our dependency. We're going to pull in our Go dependencies, and then we're going to use a Golang compiler to build the Antrea code. And all of this is going to happen inside the Docker. And at the end, we're going to produce a single Docker image for Antrea, which includes all the binaries and all the bits and pieces you need to deploy Antrea in a cluster. While this is going on, in the second terminal, also let me increase the font, here we go. I'm gonna cd into that same directory, and I'm gonna provision the cluster using the provision.sh script that Cody mentioned. Now, if I go to the Antrea repo and I go to test E2E here, we give some detailed steps on how you can provision a Kubernetes cluster and run the Kubernetes components in that cluster using Ansible playbook and creating the VMs using Vagrant. So I'm just going to be using that script here to provision the cluster. Let me just make sure that it gets started correctly. Okay, so it's gonna bring up two virtual machines, and it's gonna install the dependencies for Kubernetes on them, and then it's gonna start running the Kubernetes daemons. All right, and I think my build is still ongoing here. We're at the stage where we run the Go compiler. Okay, so while this is going on, it's gonna take a couple of minutes. I'm gonna hand it over back to Cody so we can give a quick intro to Project Antrea.
Great, thanks, Antonin. So I will reshare my screen. If you could stop sharing yours for 1 second.
Okay, I'm still sharing. Yes, I lost my Zoom window, which is not great.
So while he's tracking that down, let me tell you a little bit about Project Antrea. So it was started a little less than a year ago. We actually announced it at last year's KubeCon. That would have been in 2019 at the end of the year. And Project Antrea is an open source CNI, which is a container network interface network plugin, providing pod connectivity and network policy enforcement with Open vSwitch in Kubernetes. So the key thing to take away from that definition is, we are a plugin for Kubernetes that actually takes care of all the plumbing necessary to enable network connectivity for pods. In addition to that, we also can enforce upstream network policy as well as have our own enhancements for additional native policy features. And all of this is built on top of Open vSwitch, which is a very stable software-defined networking component within the Linux kernel. Now, Project Antrea, again, it's very young, but it's already has 683 stars on GitHub, 116 forks, and we've got multiple parties that have jumped in and started contributing to it. And so we're really excited that, for being so young, we've already got um, uh, a lot of excitement around the feature sets that we're adding, and the aggressiveness of our roadmap. And so we encourage you to go take a look at what's happening at the end of this presentation, because I'm certain that there are some things that you as developers can help us to even go faster with. One of the things that we wanted to focus on in building this project is we wanted to make sure that container networking was easy, right? It's networking in general can sometimes be difficult if it's not something that you deal with all the time. So we wanted to make sure that we had a lot of usability tweaks and diagnostic tooling within the project, so that you could quickly diagnose and surface any problems that you might have in setting up networking in Kubernetes. We also wanted to make sure that it ran anywhere. Kubernetes runs in a lot of different places now, right? You can run Kubernetes on premise. You can run it on top of vSphere, or you can run it um, on a public cloud. Either do it yourself, or use a distribution, or you can run it inside of something like um, AKS, or GKE, or EKS, which are all managed Kubernetes offerings from a lot of the different public clouds. And so wherever you run it, we wanted to make sure that Antrea could provide policy enforcement capability, and in some cases the connectivity pieces as well, to make it easy to do networking in Kubernetes wherever you're at. So let's take a little dive into what we actually mean by Kubernetes cluster networking. When you spin up a Kubernetes cluster, the nice thing about the way that Kubernetes handles workload scheduling, and the way that it exposes it to the network, is every single workload or pod gets its own IP address, which makes it a lot easier to deal with. So I don't have to do crazy things like map and managing port numbers like I used to do in the Docker days, if you will. Um, but what that means is that Kubernetes plugins that provide networking support have to implement basically three different types of uh, packet transport patterns. They have to be able to allow pods to communicate directly with other pods. They have to allow pods to communicate with a service. Within Kubernetes, there is a service abstraction, which basically allows you to signify a set of pods as providing some service. And so it's a form of load balancing that happens at layer 4. And so we have to have some way to either interact with the native uh, load balancing function called kubeproxy, or we have to implement that ourselves. And so Antrea actually can do both. And then finally, it has to be able to take traffic from the outside world and map that onto or route that to a service. If you look at where it falls in terms of the networking stack, right at the very bottom of the stack is where we typically have the underlying fabric. This is the network that all the hosts that are part of a Kubernetes cluster are connected to. At the top of the stack, where you see ingress and service mesh, that's where we are dealing with things like load balancing at the edge of the cluster, so like L7 proxies, and service mesh, and it is dealing with proxying traffic between applications in the cluster. So if you look at it, ingress kind of handles the north-south direction, where service mesh handles east-west. And in the very middle, we've got cluster DNS, which basically does what you would think it does. It's name resolution for DNS. But the things that we're focused on today are the CNI network plugin and the service load balancer, which we've already defined what some of the responsibilities for that are. One final thing, we've talked about where we can run Antrea, but not only can we run it anywhere Kubernetes runs, we can also easily support Linux and Windows. Since we're built on OVS, it provides a very common abstraction for us for running Kubernetes. For Antrea, we program against OVS, which as OVS advances and adds new features, and we add new features to Antrea, we don't have to have two separate implementations and two separate networking stacks that we're dealing with across the operating systems, which is a huge advantage. So to talk a little bit about OVS, OVS is, again, a very stable um, piece of the Linux kernel at this point that provides, software defined networks. And we chose OVS is because we really wanted a high performant, programmable switch that is going to allow us to be aggressive with the way that we add features to the CNI. And we have a really solid set of stable networking primitives by which we can build and compose those functions. We've talked about it being portable, but not only is it portable and programmable, it also supports a lot of advanced features like DBTK, AFXDP. Additionally, we can use things like SRIOV and do you know offload of a lot of the OVS data path onto SmartNICs as well. So OVS is a really advanced core data plane and data plane component that we use within Antrea. So looking at the architecture of Antrea, Antrea was built with Kubernetes in mind. It has a very Kubernetes centric view of the world. And so it uses, for example, Kubernetes for the storage of a lot of its configuration objects and state. So we use things like CRDs. But more importantly, we're able to plug directly into, as a Kubernetes controller, into the Kubernetes lifecycle and actually see events like pods being added, network policies being added, etc. And the way that Antrea works is there's an agent deployed onto every host, and that agent interacts with OVS in the kernel and is able to take commands from or to take configuration from the central Antrea controller, whether it is to do with what network policies should be set up for edge firewalls on the applications, or what IP addresses to assign, etc. All of that takes place from that Antrea agent programming the OVS data plane on each host. And this distribution then is also very efficient as well. For example, we're able to centrally calculate all the reachability that is allowed between the pods based on the network policy that's been applied, and only give the pieces that are necessary out to each agent so that we can keep that distribution of configuration and updates very efficient. And the final thing I'll touch on here is what we do with our policy model. Within Antrea, um, we have built a full set of policy capabilities and are continually adding to those as well, that allow policy delegation, that allow, for example, multiple tenant capabilities within Antrea so that we can do things like um, allow developers to build the policies that they need around their application because they're the experts around ports and protocols, et cetera. And then we allow um, cluster administrators, platform operators, to build policies where they need to either protect shared services or maybe have some more global policies that they care about to protect the applications as a whole across the cluster, or to protect tenants from each other. And we're not going to focus a lot on the policy today. We're going to be looking actually at a lot of the pieces around observability. And what I have on this diagram here is showing the different ways that you can interact with the Antrea control plane. And one of those pieces is Prometheus, providing observability functions, right? So we expose a lot of the metrics and the operational data that's happening in the data plane into Prometheus. And what Antonin's going to do today is to show us, how do we extend that, and how can we make use of that. Additionally, we have things like AntCuddle and Octant UI that provide additional visualizations for things like trace flows, and other diagnostic information about the health of the Antrea control plane. So by now, Antonin, I would assume that we've had enough time for the provisioning to be completed, and we have our Kubernetes cluster stood up and ready to go. So I'm going to hand it back to you to explain a little bit about what we're doing around Prometheus.
Yes, thanks, Cody. I started sharing my screen again. So yeah, you're correct. We had enough time to build Antrea. That only took like a couple of minutes, and thanks to Docker caching, it only gets faster for the second time you need to do a build. We also had enough time to provision our two Vagrant VM nodes, which we're going to use to build like a Kubernetes cluster. So that took a little bit longer. That took about like 7 minutes. But that's something you only need to do once or quite infrequently when you developed for Entria. So if I go back to that README guide I showed before, it shows how you can set kubeconfig for the clusters that was just created. And that's important because it lets you use kubectl to inspect your cluster and look up information about it. So let me set that environment variable here. And so once I've set this environment variable, I can just use kubectl to look up information about my cluster. Okay, and right now it does show my two nodes running the latest version of Kubernetes, but they're both in the not ready state. They're not in the not ready state because there is actually no network plugin providing the networking functions for the cluster. So when we created the cluster, we told Kubernetes that we're going to use like a CNI plugin, a third-party plugin, to provide networking functions in the cluster, but we haven't deployed one yet. And as a result, as network is not working in the cluster yet. And if we look at the different pods in the cluster, we're going to see that our core DNS pods providing like the DNS services inside the cluster are currently pending, they're not running. And that's because they're in the pod network and they rely on that CNI plugin to provide the networking functions and connect them to the cluster. So what we're going to do is we're going to deploy Antrea now in our cluster. And going back to that README again, we see that there is like a script that you can use to push to load the Docker image we've just built locally using make build in the Antrea repository, to push it, to load it into every node along with the Antrea deployment YAML. And once everything is loaded in the node, the script is going to apply the YAML in the cluster, which means that we're going to run Antrea on every node. We're going to run the different Antrea components. So let me copy that script here. Okay, I'm going to cheat a little bit here. I know that there is like a Prometheus flag you need to pass if you want to enable the Antrea components to export Prometheus metrics. And so I'm going to use that flag right away so we don't have to deploy Antrea again later. So what that script does is, as I said, yeah, it's going to save this image that we just built locally to a tarball. Then it's going to SCP the tar file into each of the two VM nodes. And once this is complete, it's going to apply the Antrea YAML.
So while this is doing that, Anton, and the reason that we do this is we want to get the latest image that we built. But somebody running Antrea in a production environment, they would probably just pull that image from a repository, correctly?
Yeah, that's correct. They wouldn't even
Yep.
use this script. They wouldn't use this script because they would just pull the latest Antrea that we've released, which is currently 0.8.2.
Got
Yeah,
it.
they wouldn't need to build the image themselves. We host all the released images on Docker Hub. Well, that's perfect because I think we just talked for like 20 seconds. So I think that gave like all the Antrea components time to be created. And yes, if I look at the pods again, now I see that I have one Antrea agent running on every node. Provide these flags so we get a bit more information. Yeah, so we have one agent running on every node. We have an Antrea controller, which is a centralized entity, which is used to distribute network policies to the agents. And now if we look at the core DNS pods, we see that they're in the running state here. So if I do get nodes again.
So another question, Anson, and on as you're looking at that, and so there should be an agent then for every node that's running, correct?
That's correct, yeah. Because
And
we
then the
use
controller.
we
Oh, go
use
ahead.
it.
I'm sorry.
Yeah.
And then the controller that's what's actually watching, when pods get created and such, and basically figuring out what we need to do in terms of plumbing that pod, and we send that in and filtering traffic for that pod. We send that out to the agents as that happens.
Yeah, the controller is specifically for network policy implementation. We don't really use it for anything else right now. The
Okay.
networking functionality, the CNI functionality itself is handled entirely
It's
by
all in
the.
the agent.
And that's kind of like
Okay.
something that's different from an alternative solution like OVN, which is also like OVN Kubernetes is also a network plugin that supports Kubernetes. It's also a CNI implementation, but in their case, they rely on OVN running, and they have like kind of like a centralized entity which is like leverage every time a pod is added to the cluster to provision the networking for it. In Antrea, that part is completely distributed and handled locally by each agent.
So it sounds like Antrea is a lot lighter weight in terms of the way that the controller and the control plane is implemented.
Yeah, and that's really because Entria is not just like it's not like a full SDN solution, right? It's something that was designed specifically for networking, and so we focus on the Kubernetes networking model, the Kubernetes networking needs, and what we want to support as part of Kubernetes. In the case of OVN and OVN Kubernetes, you need to run OVN first, and that piece itself has like a lot of complexity and northbound, southbound APIs, and so with OVN Kubernetes, you just like integrate with that. And so every time a pod is created, to give like a concrete example, like the agent part in OVN, because they also have an agent part, is going to block until the centralized entity can annotate the pod with the IP address, for example, and then they're going to configure the networking locally. In
Okay.
Antria, we don't have that asynchronous piece. We can handle the CNI calls from kubelet directly on the node.
Makes sense. Okay, so we have our Kubernetes cluster set up. What I'd like to do, if you give me the screen back for just 1 second, I want to talk a little bit about what Prometheus does, and then maybe you can actually show us how we're using Prometheus within Antrea. So to
Perfect.
get started here, we'll take a look at, we've got our successful creation, right? We've deployed Antrea. So now let's take a look at what is Prometheus. So Prometheus is a way for us to capture real-time data, and different statistics about the operation of our software. There's a component that is actually a library component that we compile in with the Entria code base that, as things are happening, if the different things that we're calculating, we write to that library, and what ends up happening is the statistics that are captured, they get published to a endpoint, and that endpoint then is scraped by a separate Prometheus server that collects all that information. And again, for in our case, we're actually publishing that information on our agents as an endpoint. So that means that every node that's running an agent is going to have its set of statistics that are getting published, and we have a single Prometheus server going around and collecting all of that information. And when it collects it, depending on the type of statistic and what we're looking at, right, it can store that information into a time series database that can then be visualized in a tool like Grafana, so that we can draw really nice charts and graphs, or look at various gauges over time, and see how things are changing within the cluster. So that gives you just a really basic understanding of what Prometheus does. Prometheus is far more has far more features than what we're going to get into today, in terms of the way that you can actually um, describe the types of data that you want to capture, how you want to query that data. There's a whole advanced query language for how I read that data, and mix and match that data that gets presented. But for now, just understand that the data is created in the Entria component. It's collected by the Prometheus server, and then we're going to visualize it in Grafana. So I'm going to hand it back to you now that we've kind of walked through that, Antonin. Let's see how Antria is using Prometheus today.
All right, there we go. So this is where we left off. And so as Cody said, we're gonna now log into the Prometheus server and take a quick look at the metrics which are available. And then we're gonna move on to Grafana visualization. So what I'm gonna do is I'm gonna look at the services in my cluster. And remember, when we pushed Entria with this command here, we passed the -- Prometheus flag. And so when we provide this flag, we're automatically going to deploy a Prometheus server as a Kubernetes deployment in the monitoring namespace. And we're going to create a node port service for Prometheus that we can use to connect to the Prometheus server UI. And so we can find this node port service here. and it's telling us that it's running on port 30,000 on every node. It's an out port service, so I can use each node's public IP to connect to the service. And that's what I'm going to do here. Let's look at one node's IP. This is a node IP here. Let's take it and port 30,000. There we go. So this is like a very simple UI, which is why we're gonna take a look at the Grafana UI after. But what we can do is we can see here in the drop-down menu the different metrics we export for both the Antrea agent and the Antrea controller. And one of them, for example, is local pod count. So we can take a look at this metric here. And here we have it in like just plain numerical format. We can also like access a graph to see how it changes over time. But basically the state we're in right now, let me go back to that, is that it's telling us that on this node, the node with the IP address that ends with .100, we have two pods running. And those are actually the two core DNS pods providing DNS functions in the clusters that I mentioned earlier. And on the other node, 101, we have like a single pod running. And if I go back um, to my terminal here, we can see that this is actually the Prometheus server pod. So kind of like all three pods are accounted for. All the other pods are actually running in the host network. So Antrea is not responsible for providing like networking functionality for those. They're actually in the same network namespace as the node, not part of the cluster network per se. All right, so now that I've shown the Prometheus UI, we can go to Grafana here. And what we're gonna do is we're gonna create a dashboard and add a query for that metrics we just looked at. So I already connected Grafana to our Prometheus server. I already added it as I added Prometheus as a data source for Grafana, so we don't have to go through this again. But it's as easy as just providing the IP address for one of the nodes and the port number. Now let's go to the available metrics. You see that they are aggregated and that we have a section for Antrea here. And let's look at the one we've been looking at, which is entry agent local pod count. Here we go. So let me reduce this. That's 15 minutes maybe. Yeah. So basically it started at that time, which is when I deployed Antrea with Prometheus in the cluster. And since then we haven't had like any changes because we haven't been like creating or deleting pods. So that number has stayed at 2 for one node and 1 for the other node. So yeah, so that's one metrics we have. You have the full list here. I think we also publish it in our Prometheus documentation for Antrea. Another metrics we could look at is the OVS flow count. But basically, you have an idea of what Antrea metrics look like when visualized in Grafana.
That makes a lot of sense, Anton. And so I'm curious, right? I've downloaded Antrea, I've installed it on my cluster, right? I'm monitoring, but we're noticing that ever so often uh, we're getting intermittent connectivity to the applications on our cluster, and we notice that it happens when the number of connections increases really quickly to our cluster, and so we were looking through that list of metrics that you had on Antrea and noticed there's really nothing there that talking about how we're handling connection tracking. We think that maybe this issue might be related to connection tracking. So would it be easy to add a statistic that would tell us a little more information about how Antrea is handling connection tracking?
Yeah, I think definitely, and it's actually a good idea. I think the problem you mentioned is kind of like a well-known problem in that container networking space, and that's because by default, the connection tracking table on Linux has like a fixed size, which is going to depend on the distribution and your kernel and everything, but it's usually around like 250K, for example, 500K, and something like this. And because on Linux, you also have this TCP connection state, right, called time wait, which is a time window during which like the socket is not going to be reusable for new connections. Um, um, for new connections within like a time window of by default 120 seconds. It's very easy, and during that time window, the connections are going to stay in the connection tracking table. It's actually very easy to just like run out of entries in your connection table. And at this point, when you try to commit a new connection to the connection tracking table, your packets are just going to be dropped, and you're not going to be able to establish that connection with Antrea. And
Oh, that's
so
fantastic.
yeah,
So
it's definitely possible in Antria to add a new metric that would like count how many connections we're currently tracking in the connection table, so that you on your side as a cluster operator can take action.
fantastic. So let's walk through the process of how I might actually make that happen. If you don't mind, I'll share my screen again. And what we'd like to see here is, if I had this problem in the real world, what would I do to affect a change in this upstream project? And so, what I'm going to do first is, I know that I want to do this enhancement request. So I probably need to go over to the project and actually. Um, Oops, sorry, my screen switched on me. Let's try this again. I need to go over to the project, and what we're going to do is actually create uh, a new issue, right? In GitHub, that's how we actually track issues for our project. And actually, we take into new issues into the project if we want to make enhancements. So I click new issue, and I am going to click on I guess this is a feature request, right? Since we're adding something new. So,
Sounds
and the
about
nice thing about what we've set up from our templates, perspective is it's going to tell us, what are our problems that we're having, and how do we want to go about fixing those. So, this is going to bounce on me right quick because I've already prepared some ideas on maybe what I would want to put as this problem. So let me just cut and paste those in there. Okay, here we go. So I'm going to describe this problem as, oops, go. Well, it didn't like the cut and paste. So how about we just type it? Sorry about that. The fun of live demos. You never know what you're going to get.
You're gonna showcase your typing skills.
That's right. That's right. Yeah, it's not gonna paste. So that's okay. So basically, I'm going to describe my problem here. Actually, before I do it this way, I'll just do a new issue so I don't have to type all those out again. Feature request. All right, we'll start here. So basically, we are, my team is seeing a ceiling on the number of connections allowed for certain workloads. Right. So as we add additional volume, connections are dropped after a simultaneous um, connection threshold is reached. And what we think it may be due to connection tracking table saturation. So what do we want to happen? Well, I think it would be useful to have a new metric showing the current number of connections in the connection tracking table. And we think that anything else we want to add, let me think here. This metric would probably be useful for configuring, would be useful for configuring connection tracking table sizes to avoid any type of problems in the future. And it would also help us help generate alerts, right? If we're getting close to having a problem, so that hopefully we can come in and either have an automated response to this, or we can have one of our engineers take a look at it. So I'm going to put all of these things in. I'm going to give it a title. This is basically I'm going to call this connection tracking metrics. I'm going to submit this issue. So Antonin, now that I've submitted this issue, how would we go about actually picking this up and adding it to the existing Antrea code base? I'm going to hand it back over to you.
Yep. Good thing I wasn't the one typing that. I type with 2 fingers, so that would have taken a while. All right.
Well, it wouldn't have been a real demo if something didn't break.
So I'm going to share my screen here, and I'm going to refresh that page. And okay, I'm going to see, I'm just seeing that issue you just opened. So the first thing I'm going to do is I'm going to assign it to myself before someone else from the team claims it. And that would be kind of like awkward if somebody pushed a PR and a fix before I have the opportunity to do that in that presentation. So I'm going to assign it to myself. And then I'm gonna start working on it. So we have like documentation in the Antrea project about all the different like workflows. I mean, the expected workflow as a contributor, but it's all like pretty standard. So let me go back to my terminal, and I'm currently in the master branch of the repo that I just cloned at the beginning of the session. So I'm going to create a development branch, which I'm going to use to add this feature. And let's look at the name of the issue again, connection tracking metrics. I'm going to call it add connection tracking metrics here. Okay. So I'm gonna be working on that branch. Then I'm gonna push that branch to my fork, and I'm gonna open a pull request against upstream Antrea for the other contributors to Antrea to review. And let's say that I'm not very familiar with a code base, but I want to take care of this issue because honestly, that's an issue that would be like I think pretty good for someone who's interested in making a contribution to Antrea for the first time. So what I'm going to do is I'm just going to look where in the Antrea code base we currently register metrics. Sorry, I'm still in that directory. Okay, let me do grab. Okay, and I can see. Okay, that's a bunch of stuff. But I can look here and I see that for the agent we have that metrics package here and that Prometheus.go file, and we seem to be registering like a bunch of metrics. And one of them is like pod count, which is a metrics we looked at in Grafana before. But let me open that file and see what's going on here. Okay, awesome. So I see that there is a pod count metric here, and it's using like a gauge, a Prometheus gauge, to define these metrics. And the gauge is different from a counter. A counter can only be incremented monotonically, whereas a gauge can go up and down, which is what we expect for the number of local pods and what we would expect for the number of connections as well. So let me just copy this, scroll down to the end here, and I'm going to define my new metrics. Let's call it connection count. Antrea agent connection count is going to be the name that we export to Prometheus, and number of connections on local node, which I'll manage. Let's keep that description for now. We're going to put it in like alpha stability level because that's something we're still working on. We don't know if everything about that metric is going to be stable in the future, or if we may change the definition. All right, let's see if the pod count metrics shows up anywhere else in this file. Okay, I see that we're registering it, so we probably need to do the same thing for our metrics. Where can I put it? I'm going to put it here. Initialize Prometheus metrics directly. Let's see. Okay, pod count, it's connection count. And if there is an error, we're going to produce one error log message. Okay, so what we've done so far is we've defined our metrics and we've registered it. So now if I were to like build Antrea and deploy it again, I would show it, I would probably see it in my Prometheus server UI or in my Grafana dashboard. And Cody, feel free to interrupt if you have questions. And um, but basically, I need to set that metrics, right? I need to increment it and decrement it when I need to. And so that's where it gets a bit tricky. But I happen to know that in the agent code for Entria, we have some logic where we pull connections. And we do that because we are actually currently working on a feature to export IPFix records about each connection for each agent in the network so that that data can be aggregated and visualized as like nice diagrams in the UI. And so basically what I'm going to do is I'm going to leverage that code, which is already like polling connections, and I'm going to see if I can use that code uh, to sorry, I'm still sharing my screen, right, Cody? You can see.
Yes, yes. Well,
Uh,
while you're switching over to that code to actually add the logic for, um, you know, recording the connections, what I wanted to just summarize here is that with Prometheus, there's basically two steps, right? You have to create the metric and register it, right? And that doesn't actually is the metric isn't doing anything yet. It's just basically telling Prometheus to put a placeholder on the scrape endpoint for that metric. And now, as he switches over to the other file, he's actually going to go about populating that metric with data.
Yeah, exactly. And so this is the file I was talking about, which is doing like a polling on all the connections. Let me go to the bottom here. Yeah. So what we do here is we're looking at all the connections we have, which are committed by Entria, and we put it in this map or array, whichever data structure it is. But you can see that if we look at the length of this data structure, what we get is the actual number of connections committed by Entria. So what I'm gonna do is I'm gonna grab that number. Right. And here I'm going to use it to increment my metrics. So the way I do that is, let's just quickly open the file we had before. Here we go. We need to import that file so we can access that new connection count variable, which we've defined and which stores our metrics object. So let me import it here. Just gonna grab it. It's package agent metrics. We import the package. There we go. And now that I have it, I can access it. So the name is connection count in the metrics package. And I'm going to use set. So I think that type of metrics gauge can support like increment, decrement operations. And in this case, we just want to set the value because that's the value we have right now. We're not using like incremental variations. Every time we poll, we get the full list of connections, and so the exact number of connections. And if I've added a metrics before like this, and I remember that set takes like a float value, and so we're going to cast our num connections variable to a float and set it. There we go. And that was actually pretty short and pretty quick because we already have that full list of connections. So that value was already accessible like very easily once you know where to look. Okay, so now that we have this, we should be able to rebuild Antrea. So I'm going to run make again. And hopefully this is like pretty fast because, I mean, if you remember the output from last time, this step took a while because we had to download all the libraries, all the Go module dependencies for Antrea. We don't have to do that again thanks to Docker cache, but we still have to run the Golang compiler to produce the Antrea binaries.
Now, when I build the new image, Antonin, I don't have to recreate my cluster every time if I'm developing, right? All I need to do is push the new image. Is that correct?
Yeah, that's correct. I'm not going to run that provision script again, but I'm going to need to run the push.sh script again, if you remember that one, because now I have a new Docker image locally. So I need once again to load it into every node and basically reapply my YAML.
And I would imagine that, in this type of edit, typically we would go in and write some unit tests. Obviously, we're constrained on time with this presentation. But tell us a little bit about unit tests while we're waiting for this to compile.
Yeah, good point. So we use Go testing framework for our unit test and our integration test. So in this case, I would say you would probably need like integration tests because you would actually want to test this by creating some connections in Linux in the connection tracking table and looking at this there. Or we could also have some unit tests because if I remember correctly, we have defined some like interfaces for for accessing the connection table on different operating systems, whether it's like Linux or Windows. And so using that interface that we mock in Golang, we would be able to generate some like fake connections and basically make sure that the whole point of the test would be to make sure that the metrics is updated correctly when we hold new connections.
Makes sense. Well, it looks like we have a new image ready.
Yes, exactly. We do have a new image ready. Now, if you remember, we used that script previously to push the new image to the cluster. Here, and I'm going to be cheating again, cheating a bit. That's something that would be difficult for a new contributor, but that's why we're always happy to provide help for people interested in contributed features to Antrea. What I need to do is I'm going to need to edit this script because this new metric I've added is actually relying on that connection polling feature that I mentioned before, right? And so right now it's not enabled by default. We still consider it in the alpha stage because it's still something we're actively working on. It's not like probably not completely stable. So what I'm going to do is I'm going to quickly update this script, which should only take like 2 minutes to add to be able to enable the connection polling, which depends on a feature called flow exporter in Antrea. It's going to be disabled by default. Basically, I'm just going to copy what we do for Prometheus. Let's call it flow-exporter. If the flag is defined, then we set the flow exporter variable to true. And let's see what we do for Prometheus here. It's going to be a bit simpler for this one because for Prometheus, we actually need to add the Prometheus deployment and Prometheus service. To the YAML here, we're just going to need to do a simple substitutions in the.
So while you're adding that substitution, I was going to elaborate more on,
Yep.
picking up issues. We have an entire curated list of good first issues, and you can select that when you're viewing issues in GitHub.
I stopped
Our
sharing if you want to show it, Cody.
Oh, sure. And while you're compiling that and pushing that, I'll share this piece here so that you can understand how to get involved. We One of the things that we pride ourselves, I think, in this project is we have an incredibly um, not only talented set of maintainers, but maintainers that really enjoy the personal connection with all those that are wanting to jump in and contribute. And they are great about being very responsive and jumping in on Slack. Start up a Zoom. Whatever it takes to get you. Um, to be successful and being able to contribute into Antrea. We have a Slack channel on the Kubernetes Slack, which we use for not only announcing information about the project and discussing architecture about the project, et cetera, but that's where you can hit up one of our maintainers or other contributors if you have some questions about how to get started or how to use this particular tool set. Maybe you're new to Kubernetes, maybe you're new to container networking in general. Definitely jump in and say hello to us on those channels. Do we have it ready deployed, and maybe we can see if that addition worked?
Yeah, so let me share my screen again if you
Okay,
want
let
to stop
me
sharing
give
yours.
it back to you here.
All right, so you're just a tiny bit early. I finished updating the script, which was like just pretty straightforward, and now the image was already built, so I'm just like pushing it using the script. If you see here, I invoke the script with that new flow exporter flag I just defined. All right, so I do hope that everything worked. Uh, I think one way we can verify really quickly, and that's something that's kind of like useful when you're developing for Antrea, so maybe it's worth showing it, is that clusters that we create with Vagrant VMs, you can easily SSH into each of the machine. So here I'm gonna SSH into the master. And on the master, we have the YAML files that we use to deploy Antrea. So let's make sure that Flow Explorer, yeah, okay, that was enabled. So my changes to the script took effect and modifies the Antrea YAML before applying it. So now we should have enabled Flow Explorer, which is going to support the connection polling, which is going to enable our metrics to be updated correctly. And
Great.
so that's what we're going to verify right away by going back to, well, maybe the Prometheus UI first. So I refreshed. Let's see.
Oh, I see it. Agent count or connection count.
Yeah, connection. Yeah. I'm having clicking issues. Here we go. All right. So we see the connection count. It's at 0 for one node and 4 for the other one. We're going to talk about this in a second, but let's just go back to the Grafana UI and maybe quickly change our metrics here. Maybe I need to refresh. Let's refresh. Oh, okay, add query. Let's do that again. Prometheus is my data source. Antrea. Perfect, it's right here. I'm going to put it on like 5 minutes and refresh every 5 seconds. Here we go. Okay, so right now we see that we have 4 connections on one node and 0 on the other one. And really that's because I'm not running like anything interesting on my cluster. In that kind of scenario, the issues that Cody described where you would like fill up the connection table would definitely not happen, right? But what I have is ahead of time for the purpose of this session, I prepared, let me see if it's here. I prepared a YAML file, which, oh, I put it in TMP, so let me copy it.
Well, while you're loading that, I was going to encourage anyone, if you have questions about what you've seen today, you can ask them on the chat, or maybe even better, you can go over to our Antrea Slack if you haven't signed up for the Kubernetes Slack, our Antrea channel there, and ask your questions. So that way we can have a chance to get back to you, because it may run beyond the hour slotted here as well.
No, I think we're almost done. I mean, on my
Excellent.
side of things. Yeah, so this is the YAML file I've prepared, YAML manifest I've prepared ahead of time. And what it does is it just creates like a deployment with 3 Nginx servers, basically. It groups them in a service, community service, and then we also create like a second deployment with 3 web clients using like um, a Docker image I've prepared ahead of time. And what that web client is going to do is it's going to loop, and every second it's going to start like a connection to the Nginx service that's going to last for 30 seconds. So after 30 seconds, we're going to kill that connection, but we're going to keep creating a new connection every second. And what's going to happen for those connections is they're basically going to be in the TCP established state for 30 seconds because that's how long we keep the connection open. But then after that, they're going to be in the time wait state for an extra 2 minutes, 120 seconds, which is a default on Linux. So basically, each connection that we create like this is going to stay in the connection tracking table for 30 seconds plus 120 seconds. So the lifetime of a connection in that tracking table is going to be 150 seconds. So we can expect that each client is going to account for 150 TCP connection once we reach like that kind of like steady state. So let me apply that YAML here with kubectl, and let's look at the pods again. Here we go. So we see our 6 pods, 3 clients and 3 servers are creating right now. And because I have a single worker node in my cluster, and I didn't untake the master to accept like workload pods, all those 6 pods are actually going to be scheduled on the same worker node, but that's not an issue for the sake of this demo. Okay, all the pods are running, so that means they must have started to create connections. So let's go back to Grafana. Oh, okay. So in the last few seconds, we jumped from 0 and 4 connections to, it's hard to right now we're at 117 and 142, and it's still climbing, right? Because every second I have like 3 connections that I'm creating. And that's also going to show, by the way, the UDP connections that are used to resolve the service by contacting the core DNS service, right? So what we have here is the UDP connections between the web clients and the core DNS service, plus the TCP connections between the web clients and the Nginx service. So that number is basically going to keep like increasing until we reach like I think it's like something like 900 or something like this. Okay, so
Oh,
we're
this is great. So now I've got direct feedback for either my platform operators or an SRE team that can actually look at my connections and begin to diagnose why we were having those issues. Maybe we need to reconfigure the size of our connection tracking table or something like that.
yeah. Obviously, this is a synthetic workload here, but having this in Antrea in your production cluster would enable you to visualize how your number of connections evolve over time and kind of like provision your connection tracking table like accordingly.
Excellent. Well,
Yeah. So
I'm going to throw up our 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 slide that shows
yep.
everyone where they can go to find out more information again. And again, I wanted to thank everyone for connecting and sharing some time with us as we showed you Antrea. If you haven't tried it, we encourage you to download it. It's very easy to install. All the documentation is either at our website at antrea.io. You can view the documentation HTML, or you can view it directly on the GitHub repo in our docs directory with all the markdowns. We've got a lot of great instructions on standing up your own clusters, installing the CNI, and hopefully after today, you've seen just how easy it is to dive in and actually start contributing features to the project and helping us improve it for everyone. So, with that, we're at the top of the hour. Again, if you have any additional questions, we would encourage you to move those over to the Antrea Slack channel. And thank you again for attending.
Thank
Everyone,
you.
have a great day.